And this time, again, we are dealing still with the data visualization only, but we are going to use another library which is built on top of Matplotlib, but much more beautiful, very beautiful, customizable graphs you will be getting. That is SEABORN. It is built in top of, I repeat once again, it is built on top of Matplotlib only. Okay, it is built on top of Matplotlib only, but way better than Matplotlib is. Okay, so actually what happens is SEABORN library by default has some data set in this. So you can use your data set. One way you can use your import your own data set like Titanic data set or any other data set, but it has inbuilt data set available as well. For practice, you can use them. So for example, let me, how we import our SEABORN, just simply you have to use import SEABORN as analyze SNS. Okay, this is optional. As an SNS is optional. You can ignore it as well. You can ignore it as well. You can just use import SEABORN. You can just use import SEABORN. Okay, so SEABORN library will be imported. Now you can use this. Okay, as per your requirement. So SEABORN has been imported SNS. So now whenever I will want to refer my SEABORN, I will be referring only SNS. So I'm saying SNS, see properly, dot load underscore data set. It has several data sets, I'm using one very famous known as tips. Okay, and saving it in my own data frame known as DF. So SEABORN has several data sets available inside. If you want to do the practice, you can go to the documentation of SEABORN and see what different data set is available, and you can use them without referring to any website. It means without downloading data set from anywhere. You can use their built-in. For example, they have a flower data set, iris flower data set. So you can use that as well. Okay, they're different. So I'm using this, and what it will do, it will load from the SEABORN and save it as a data frame in my variable known as DF. Let me run this. Okay, and if I want to see this data set, how can I see the top 5 rows? df dot head. Okay, this is the data set which is available to me. Okay, this is the data set which is how many parameters? 1, 2, 3, 4, 5, 6, 7. 7 parameters are there, or 7 variables are there. Which is total bill. This is tip. This is gender, male, female. This is smoker or not. This is day. This is what is the day of the week. This is time. Actually, this is a restaurant data set. This is a data set of a restaurant, which is giving the information. Normally, it is used for predicting something, predicting the tip. How much tip a person will be giving. How much tip a person will be giving, depending upon if his total bill is this. What is his gender? He's a smoker or not? What is the day of the week? What is the time he went for the dinner or the lunch or something? How many people were accompanying him? Means he was alone or alone with the 2 people or something. So this is something like that. Okay. So we have 3 numerical columns. If you can observe, total bill, tip, and size, and rest of them are categorical or object columns. Okay. And if you want how many rows and columns are there, we know that. How can we get the information? df.shape. In this data set, we have 244 rows. Okay, 244 rows and 7 columns, and that we can witness 1, 2, 3, 4, 5, 6, 7. Okay, and we want more information, then we can go df.info about each column. So total bill is what? A floating point number. You can observe it, 16.99. Tip is also a floating point number. Observe, tip is a floating point number. Okay, your rest, your size is an integer, right? 232. You can observe size is an integer. Okay, and rest are your categorical column. Somebody is male or female, smoker or not smoker, what are the days or time. Sometime it will be indicated as an category columns, and sometime it will be indicated as an object. One and the same thing here. Is it fine so far, everyone? Please tell me. This is how actually we work on a machine learning project. We first of all read a file, and after reading the file, we just go to the 5 rows to get an insight of the data set. Okay, what this data set is actually having. Okay, then we check, okay, how many rows are there, how many columns are there. Then we identify, okay, out of this, which will be my output variable or target variable or the level. Okay, so you should understand, okay, in this case, we know what is my target variable. Target variable is step. I want to predict step. So this is my target variable. Rest are my independent variables. This, or input variables. So my target variable or the label is tip, or my dependent variable is tip, and my independent variables are this. So we can say as this well, this is my y and these are my x parameters. Understand how do we analyze? We understand this way. What is my requirement? I want to guess tip. So tip becomes my output variable, right? What I want to guess? I want to guess tip. So tip becomes my output variable. Rest becomes my input variables. So as my tip is dependent on rest of the parameters, tip becomes dependent variables and rest becomes independent variables. Please tell me, is it fine what I'm saying? Are you getting an idea what I'm saying? What is my requirement? My requirement is to guess the tip. What will be the tip that is given to me? So this is my output variable tip. And I have to guess tip based on these parameters like total bill, sex, smoker, day, time, and size. So these become my input variables. Okay, so tip is dependent on these variables. So tip will be known as dependent variable and rest of them will be known as independent variables. Is it okay, everyone? Please tell me. I'm not able to hear anyone. Please.
Yes, sir.
Is it fine? Get an idea? How do we recognize what is my output variable and what is my input variable? Is it okay?
Yes. Yes,
okay.
Sir.
In Titanic dataset, what was my output variable? Remember? If you can give me an answer. In my Titanic dataset, what was my output variable? If I load it, can you tell me? Let me load it here, so that I will later on, or I will delete it here itself. If I load it here, df1 equals to pd.read_csv, and my file is in the D drive, I think name is Titanic 1.csv. Okay, what happened? File does not exist. Okay, I didn't import the pandas. No issue. Import pandas as PD. Okay, let me check the first 5 rows, and now you can tell me df.head, which is my output variable. See, so you should ask me, sir, what actually you want to predict? Simple, as simple as that. Okay, not always a data set will be given to you, and you and I'll do the machine learning model. You will of course ask, sir, what output you want from me, right or wrong?
Yes.
I'll give you a data set. You will ask me,
Yes,
sir,
sir.
what you want from me? First tell me. Okay, you have given me a file. What do you want to guess from me? So what you will say? Simple. I will say, no, I want to say, depending upon passenger class, name, sex, age, siblings, parent, and fear, please tell me whether the person will survive or not. If I feed this parameter, passenger class is 3, name is this, sex is this, male is this, siblings is this, passenger is this, fear, tell me, will he survive or not? So now can you tell me what is my output variable?
Survive.
Yes. And rest becomes my input variables.
Yes.
Is it fine now? Now everyone is clear. How do we identify? Always,
Yes.
always depending upon our task. What is my task is? Here my task is to classify whether the person will be survived or not. And here my task is what? To guess how much tip will be given. How much tip will be given. And in our machine learning, simple machine learning, we have 2 kinds of problems: regression problems and our classification problems. This is, we are classifying whether he will survive or not survive. These 2 categories are there: survive or not survive. But when we are getting some continuous output, it may be 1.01, 1.66, 3.5. So it, somebody may give 2 rupees tip, somebody may give 2.35 tips. So it can be fall in any range, any number. It can be 2.35, 2.46, 2 point something. You cannot separate them as a category. So when your output is continuous, right, then you go for regression. We call it as, this is a regression problem. Okay, this is a regression problem and this is a classification problem. So normally in machine learning, you will find 2 kinds of problems. One is regression problems. Example, you can get an idea. If I ask you, tell me what will be the stock price of Apple tomorrow? Stock price of Apple. So will it be classification or will it be regression?
Regression.
Regression. Perfect. Okay, it can be anything, right? It can be anything. 42 rupees, 53 rupees, 543 point something. If I ask you similarly, tell me what will be the price of petrol tomorrow? What it will be? Regression or classification?
Regression, sir.
Yes, yes, perfectly. Now you people are perfectly clear. What will be the temperature tomorrow? Now?
Regression again.
Yes, again, regression. What is the humidity tomorrow?
Same,
okay,
same.
so same regression. Now see the different cases. Somebody came to my car showroom. I took up his data. I want to find whether he will purchase car or not. Whether he will purchase car or not. What kind of problem it is? Classification, right? We are classifying whether he will purchase or not. Okay.
And which model maybe again?
Pardon?
Which model again? Suppose we have 5 models. So which model again? It would be classification, no?
Yeah, it will be classification. It is classification, right? This is a classification. Similarly, I purchase a lottery. Okay, what is the means? I will get a lottery or not? It is a classification or a regression?
Classification.
Simple classification. I hope it is clear now. So when we are classifying into different classes, suppose I give you some height, some weight, or some BMI, 3-4 parameters I give. This is the height, this is the weight, this is the BMI. Tell me, depending upon that the person will be male or female. Depending upon, yes, it is a classification because you're dividing them into categories. He will belong to a male category or it will belong to a female category. So you should understand, first of all, whenever somebody asks you, okay, task, first understand the task. What is the task? Okay, this is the task. Normally, when you will download the data set from somewhere, so they normally mention what is my output variable. Here it is mentioned there. And always remember, there will be certain rules. Okay, for example, you have a unique value in each row. If you have a unique value in each row in any of the data set, there is a column in which you have unique values in each row. I'm repeating once again, you have a data set in which there is a column, and in that column, in each row, you have a different value. So you will never ever use that column for building your machine learning model because it is changing every time, right? It is unique for each row. So it cannot help me in predicting any task. It cannot help me in predicting any task because it is changing every time. For example, if you see here a name, every person may have a different name, right or wrong? Every person may have a different name, but let it be repeat. So will the machine learning model, simple thing. So it will tell me, will this name help me out in my building machine learning model?
No, sir.
So we will never ever consider thing. Similarly, there is an index column. There is an index column. So will we consider that for building machine learning model? Please tell me, everyone. There is index is given 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Will you do that? Right?
No.
Please, everyone. Others, please tell me.
No, sir. No, sir.
Okay. Similarly, suppose there is a column known as phone numbers. There is a column known as phone numbers. Will you use that? Because every person will have a different phone numbers. Every person will have a different phone numbers. So that means anything which is unique, right, will not help you out in building your machine learning models. So we have to drop such columns. Those columns are of no use for us. So whenever we will be building our machine learning model, probably tomorrow we will be ending of a SEABORN, most probably. If not tomorrow, then day after tomorrow, definitely we will to start our machine learning. Okay, so we have done till EDA part, means our 80% of the task has been done. We will be studying at least 6 to 7 machine learning algorithms, and we'll be implementing them. Main task, as I told you, whenever you will be working as a machine learning engineer, 70% of your time you will be spending on EDA. How the data visualization, extracting insight. For example, this information, how will you come to know that this name will be dropped? When you will be knowing, okay, this column, when you will visualize the data, you see the data, okay, this having name is not something which will communicate some information to me. Let me drop it. Right, yes. Everyone, right? This is the thing. This is when we explore our data, then only we are going to come. Suppose similarly, there is a column which is constant all the time. All the values 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. Will it help me out in predicting something? If it is all the time, it is 1. Right? So you have to think about it, which is suitable for me, which is not suitable for me. Okay, you have to plan it accordingly. Suppose in classification problem, a constant column may be not of our help. But in regression, it depends. what is that output is coming? Suppose it is having all the time one, a column is having 1 1 1 all the time, and you are getting values always as a base around 1, 1.1, 1.2, 1.3, 1.4, 0.9, 0.8, but 1 is your scale. Then you have to think about, okay, should I keep it or should I drop it? Okay, that is the thing. So you have to think it accordingly. What columns are useful for me? What columns are not useful for me? I hope it makes sense, everyone. Okay, so I'm starting. So yesterday we started up a SEABORN library, and as I told you, it's built on the top of Matplotlib, and we imported our SEABORN library and created an alias known as SNS. Now within this SEABORN library, we have some built-in data sets. So we imported some built-in data sets. For example, tips is a data set which is corresponding to a data set of a restaurant, and we just check this top 5 rows. So we get an idea about, okay, there are a few columns like total bill, tip, sex, smoker or non-smoker, day, time, and size. Okay. Similarly, after that, we check, okay, what is the shape? Is how many rows are there and columns are there. So columns we can directly see 7 are there, and in total there are 244 rows. After that, to get the more information about those columns, we use df.info, which give us the information that there are 244 non-null floating point, 244 non-null rows available for the total bill, and the data type is floating point. We can observe that from here as well. Tip is also a floating point, 244. Sex is a object column or a categorical column having all non-null. So one conclusion we can make from here, as it is mentioning in my size is 244 directly, right? My size is 244. My 244 rows are there, and everywhere I'm getting 244 non-null, 244 non-null, 244 non-null. That is 100% sure that I don't have any missing values. Okay, because it is itself saying 244 rows are there, and this info is itself saying 244 non-null. That is 100% guaranteed that there will be no missing values. Okay, so let's verify that whether there are missing values or not. So that we have already seen how to use that. df dot is null. Okay, df dot is null will give me true and false values, but that will not give me a clear picture. If I run this, I'll get some true and false values. So better to visualize that, use some method over there. Okay, it will tell me that every column has no null values, and we can verify. Although that information was available from here only, we get, okay, it has 244 rows, and every row has 244 non-null values. Immediately I got an idea, okay, there are no need to check the missing values, and that has been confirmed here. That has been confirmed here. There is one more way to confirm there. Although it is numeric representation, you can also represent it in pictorial representation. Any numeric data, you can represent in form of pictorial representation. For example, I want to see same thing. I want to see same thing, that is null values, but I'm using another plot now. Until now, we have not used any plot of SEABORN library. Now I'm going to use one plot of SEABORN library, example, heat map. SNS is an alias which has been created for SEABORN. Okay, so I'm using that alias, and I'm saying SNS dot heat map. Okay, I'm simply saying SNS dot, yes, please.
Sir, in the previous line, like df dot is null dot sum, no, sir?
Yes, yes, yes.
Why are we putting sum there, sir?
I should slap you. We have understood it earlier as well. This is second time I've repeated. Remember, I've told you earlier as well. What happened is that if I remove this sum, okay, what it is going to give me for every column, that is total bill, total tip, it will simply show in every row there is true or false. Means what we are doing, it is nothing but giving me some information. It is null. It is checking. See the name, read like English. df dot is null. So it's getting some information. Means what information it is checking is null. Means is particular value null or not? Means missing value is there or not? So for every entry, it is going to give me true and false. If we run this, check it. For every entry, it is giving me true or false. If there will be any missing value, there will be true. Now is it clear, Afreet?
Yes, sir.
Okay, it is giving me, if it is null, it will give me true. If it is not null, it is giving me false. But I told you yesterday as well, okay, what it does, not yesterday, I think 2 days ago when we studied this pandas thing, what it does, when I put dot sum, what it does is simply treats, it simply consider false as zeros and trues as 1. So in every column, it will count how many trues are there. Suppose 5 trues are there. That means we immediately get an idea. In this column, there are 5 rows. which have missing values. For that particular column, it will show 5. Now, is it clear? So when we put sum, so what it will do, wherever there is true in every column, it will sum up that, and that information will be available here. Is it fine? Please tell me now.
Yes, sir.
Is it okay? I think you didn't revise, but you are sincere, but it's fine, perfectly fine, because I don't think so you have ever missed a class, right, Avrit?
Yes, sir.
I know, and don't mind it, yaar, huh? I speak that way only, okay?
Yes,
Just,
sir.
okay, don't take it. Okay, so what is happening? Got an idea why we have put it sum? Because only this will not convey any information. What information you are able to see right now? The middle rows are not visible here, right? 4, 2, 5. So what is, where is true, where is false? I'm not able to get it. So better is what? Let me put it sum. So in every column, wherever there will be true, means there will be is null condition is satisfied. That will be summed up, and that will be visible here now as a number. I hope it makes sense now. Come on, Nafreet. Is it fine now?
Yes, sir.
Okay. So I'm moving ahead. So I'm taking SNS.heatmap. Okay. What is a heat map? Simple. It is nothing but a way to represent your values in terms of color. That's it. In terms of color, you'll get a picture clearly. Okay. SNS.heatmap. And within that, let me pass this argument. df.isNull. Okay. And I'll get a color map sort of thing. Something like this. And you can see everywhere it is, I'm getting one color only. I'm getting one color only. And what color I'm getting? The something pinkish. Okay, something pinkish. How? Why? Because if you can see here, this color you are getting. Everywhere there is zero missing values. Everywhere for total bill, for tip, for sex, for smoker, for day, for time, size, there is zero missing value. That's why this color has been chosen for everything. If there will be some missing value, you will be seeing some lines here. For total bill, you will be seeing some lines. For tip, you will be seeing some lines. When we will be working on some another data set, you will be seeing that. That will be visible. If you're seeing only one color inside your heat map, then you can easily identify, okay, there are some missing values. Okay, so color representation, better way of color representation, heat map. Right now, you are not able to visualize anything. You'll immediately visualize within 2 or 3 minutes only. For example, okay, till now, what we done, this is the normal we proceed. We read our data set, check its top 5 rows, check its shape, check the info, what kind of column it is representing, verify its missing value. If there are the missing values, treat those missing values. Okay, treat those missing values. Okay, or you can treat missing values later on. It's up to you. Okay, after that, what we check, we find the relationship. Okay, what kind of relationship is there between these numeric columns? What is the relationship between how many numeric columns are there? If you can observe, there is total tip is a numeric column, tip is a numeric column, size is a numeric column. So what is the relationship between them? And that we can communicate with the help of a function known as df.cor. df.cor. What it will give you? It will give me correlation. It will give me correlation between numeric columns. So if I execute it, now you can verify. Here you have mentioned the numeric columns, total bill, tip and size, and same here, total tip, bill and size. And this number that you are seeing here is known as Pearson correlation coefficient. And this value will be always between +1 and -1. The whatever value you are seeing here is it will be coming between -1 and +1. Always it will come between +1 and -1. Now indicate simple. What do you mean by the correlation? As simple as that. How much your values are correlated to each other. Let me take an example. I have two variables. Okay. One variable is this and one variable. This is variable 1 and this is variable 2. Okay. So what is happening is that whenever variable 2 is changing, okay, then V1 is changing. That's fine. Perfectly fine. But if change of V2, suppose something change happens in the V2, in the same direction, the change in V1 also happens, something like this example. Okay, if my V2 is increasing, V1 is also increasing. That means that these have positive correlation. Okay, it has positive correlation. But suppose when my V2 is increasing, my V1 is decreasing. That means what? I have negative correlation. Okay, and suppose doesn't matter what is my V2, my V1 is remaining example constant. Whatever value of V2 is there, my V1 is not changing at all. That means what? V2 don't have any effect on V1. That means they have zero correlation. Is it fine, everyone?
Yes.
Is it clear, everyone? What is positive correlation? What is negative correlation? What do you mean by zero correlation? Please,
Yes,
I want
sir.
to know. Okay, is it clear? And how do we calculate? If you want to calculate that, that easily you can do. Let me show you a formula. Let me come here and type Pearson correlation, coefficient formula, how it is calculated. Take any formula that's easier to understand. That is easier. Okay, this is the formula of Pearson correlation coefficient. If you can observe it, what is that? Suppose what we are doing, we are trying to find out the correlation between two numeric columns at a time. Okay, between two numeric column or two numeric attributes at a time. So X indicates one numeric attribute, Y indicates second numeric attribute, and this X bar is representing the average or the mean value of that numerical attribute. Okay, similarly, Y bar indicates the mean value of Y corresponding numeric attribute. Okay, so this is the one. You first of all find the mean of that column, then you will find the mean of other column. Then what you will do, understand. Now your X will have many entries like this. Suppose your there is a column X, there is a column Y. We have some values like 1, 2, 3, 4 or something. We have 5, 7 or 8 or something like that. Okay. So first of all, I will find its mean value. What is the mean value? 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10. So average of this will be 10 by 4.
2.5.
Right? That will be 2.5. So I got X bar now. This is my X bar. Similarly, I will compute my Y. This is 5 plus 6 plus 7 plus 8. 11 plus 7 is 18. 18 plus 8 is 26. So 26 divided by 4. I'll get the mean value of that. That will be around 6.5. Right? So here I got Y bar. So I got my X bar. I got my Y bar. So now what is this Xi? Xi is the individual value. Now take this one. So first of all, Xi will be 1. So what you will perform? 1 minus. Can you meet yourself? Please, somebody is actually.
No,
Okay, so what we will do, we will take the first value of X, that is Xi. Okay, first value of X minus mean value of X. What is that? 2.5. 1 minus 2.5. Okay, this is your first term. Okay, multiply by yi. Yi is what? The first value of Y. What is that? 5 minus mean value of Y. What is the mean value of Y? 6.5. Multiply them. Okay, multiply them first. Multiply them. That will become first value. Okay, now compute second term. What is second term? Now Xi will become 2. So 2 minus same 2.5 multiply by what is the next value of Y? 6. 6 minus 6.5. Multiply them. Okay. Similarly, move to the next point. What is this? 3. So 3 minus 2.5. I hope you people are getting the point, right? 3 minus 2.5. Multiply by what is the next value of Y? 7 minus 6.5. Okay. Then next, what is this? 4. 4 minus 2.5. Multiply by 8 minus 6.5, because next value Y is this. Okay. Once they are multiplied, at last, just sum them. See the icon? Sum all of these. This will give you the top, it means numerator. And now similarly, you can calculate your denominator. I hope it is okay, everyone. What is Xi, what is X bar, and what is Yi, and what is Y bar?
Yes, sir.
Okay, so now you will be able to easily compute your Pearson correlation coefficient, and that's value you are seeing. So its value will be always between +1 and -1. If it is very close to 1, you will say they are highly positive correlated. If it is close to -1, you will say it is highly negatively correlated. Okay, so you should get an idea. And suppose what happens is that, let me clear all drawings. Let me come here to my work here. And suppose, so in case, now we can see it here, it is between total bill and total bill. So of course, I am expected to get 1 because we are comparing between the same columns. Okay, here between total bill and tip, how much this is? 0.67 means positive correlation. Here between tip, total bill and size, 0.59. So you can compute it. Okay, and suppose between two columns you receive a correlation very high, suppose 0.98. They are two different columns, but their correlation is 0.95 or 0.98 or 0.97 something. That means they are communicating almost same information. So in such cases, one of the column will be dropped. We will not consider it for building machine learning model because same information they are communicating. They are highly correlated to each other. So whatever information one column is giving me, almost same information is giving by other column. This is known as feature. Actually, this particular thing is known as feature engineering. Okay, so we'll see what are these are the features, nothing but if total bill is your output, suppose tip is so if tip is your my output variable, then total bill, sex, smoker, date, time and size are also known as my features. So which feature to choose, which feature not to choose? Okay, feature selection. And if you want to some modification on those features, these all comes under the feature engineering. So if I found out that, okay, two columns are very highly correlated, they have a correlation of 0.95 or 0.97, then better drop one column. Don't need to carry them another. And otherwise, it will make your machine learning model very complex. Okay, now see, you get an idea what is correlation. Now, a good indication of heat map will be coming into the picture. So I'm typing here, see again, SNS, same value. These same values, but we will see with the help of color mapping. So SNS dot heat map, again I'm using. And within this, I'm passing this df dot core. And if you want to see the, let me execute this first of all. So I get some graph, but better if you want to see the values inside, I have an argument known as anode is equal to true. Okay, now you can visualize, see properly. This is one, the values of correlation are always positive here. There is never negative, and maximum is 1 and minimum is starting around 0.48. Okay, so we can say that. So we will be seeing color maps between 0.48 to 1. So you can observe here it's around 0.48 to 1. Okay, so it indicates this is a scale actually. This is the scale you are mapping. The value is closer to 1, it is lighter. Okay, the value which is closer to 1, it is lighter on the pinkish shade. So when the value of the correlation is decreasing, it is tends to become darker. Can you observe, everyone? Please see here the scale wherever my mouse is hovering. Can you observe?
Yes, sir.
Okay. The higher the correlation, lighter is the version, and smaller is the correlation, it is getting darker and darker. Can you observe, please? Right. So your values have been mapped to the colors, and now you can verify same thing from here. Between how we can visualize it. See, by the intersection of this. Here, suppose I observe this one. This one, okay, this row. So what this row is indicating, this first one is corresponding to total bill and intersection of this total bill. So of course, between the same column, I will have a one correlation. So I'm getting one, that is a peak color. Okay, now I'm moving here. Again, this is total bill versus tip. Total bill versus tip. So correlation is not 1, even less than that. Of course, that is guaranteed. It will become so much darker. So I will come down around 0.68. Where is 0.68? Somewhere here. So this color should be coming here. Okay. When I'm moving here, again, total bill versus size. What is the correlation? Even lesser than 0.68. So it is further going to become darker. And we are getting this color now. Okay. Similarly, if we come here, this is between tip versus total bill. What is 0.68? Of course, same color is going to be coming here because it is tip versus. This was also total bill versus tip. This is also tip versus total bill. So same color. Here, tip versus tip. So same correlation is there. One is there because same column. So I'm getting the peak one. When I'm doing between tip and side, it is 0.49, even lesser than everyone. So we will come across somewhere here, which is very dark. And same thing you are observing here. I hope now heat map concept is clear, everyone. Please tell me.
Yes, sir.
Okay, we are just mapping our values with the colors. Okay, we are mapping our values with the colors. So actually, this is very good representation. The numbers don't speak that much. The pictures speak a lot of things. Pictures speak a lot of things. Okay, so you are now easily able to do that. Perfect. Now let's move to the second category of plots. Different plot. Okay, so what I'm going to plot now, I'm going to plot a plot known as joint plot. The name itself is saying joint, means multiple variables will be involved. In our EDA, always remember there will be two kinds of analysis. One known as univariate analysis. Univariate analysis. Okay, in which only one variable will be analyzed. Second kind of category will be bivariate analysis. Some people call it as multivariate analysis as well, right? So bi means two. So at a time, two variables will be analyzed. I hope it is fine, everyone, what I just said, right? If I ask you, okay, what kind of analysis we are seeing here, it is univariate or bivariate? Please see and tell me. What kind of analysis is this? Can you observe? At a time, you are seeing the relationship between two numeric columns, right or wrong?
Yes, sir.
Right? So it is a bivariate analysis that you are seeing right now. Okay, so you're seeing right now the bivariate analysis. That's the important. See, this tip versus size. So two variables are involved and their correlation is 0.49. So always you have to do two kind of analysis, univariate and bivariate, to see the relationship. Okay, in one line also you can do that. I'll tell you everything about that. Okay, so let's come to a plot known as joint plot. I'm coming to a plot. Please tell me.
Anything to explain univariate analysis?
Yeah, several things are there. I'll come to that. Don't worry. Several things.
Okay.
Not only one, several things are there. I'll come to that one by one. I will tell you there are, for univariate analysis, what kind of plots are used. For bivariate analysis, what kind of plots are used. Okay. For example, let me give you an example. We are going to plot everything. If you want to do the univariate analysis, once you can use describe function. Simple method. Df.describe. It will give you the statistical summary of that particular column, or even all the data frame. From that, you can analyze your complete column information. What the available, do that. Don't worry, within few minutes only. Okay, you can use your describe method. It will give you the information about every numeric column. Every numeric column, there's statistical summary. Everything is going to be there. Okay, there is a histogram. There is histogram available. Okay, there is box plot available. We are going to see everything. Okay, these are for numerical. If you want to do, for example, for category, these are for numeric columns, right? Describe, histogram, box plot. If you want to do, for example, your categorical column, then you can go for count plot. Okay, you want to do bivariate analysis. So one example we have seen right now, just right now we saw. Other than this, we have scatter plot. Okay, we have line plot. Okay, other than we have bar plot. Okay, so there are different plots, and we are going to see every plot. You will understand yourself if at time what kind of analysis. There are several things available. Describe function is available. For example, I want to get a numerical summary of every numerical column, statistical summary. So I can just type df.describe and see it is going to give me the complete statistical summary of total bill column. Total bill column entirely it is going to give me. Okay, what is saying? Okay, in total bill column there are 244 rows. The mean value of the bill is 19.78. The standard deviation of that bill column is 8.90. The minimum value of total bill is 3.07. The 25 percentile, this is not percentage, remember, percentile is 13.34. 50 percentile is 17.79. 75 percentile is 24.12. What is the max value? So here they are not relating among each other. It is just the information which is available. This information is corresponding to only and only total bill. This second column is corresponding to only and only tip. Third column is available to only and only size column. I hope it is fine so far. Everyone, is it fine?
Yes, sir.
Okay, so if you need a statistical summary of any numeric column, just use describe. It gives you the complete picture of every individual column. You can see immediately. You can do one by one, but better is see all the numeric column at a time. That's better. You can see, okay, but they are not relating each other, just giving information about this is about total bill, this is about tip, this is about site, and what information? Count, mean, standard deviation, min, 25 percentile, 50 percentile, 75 percentile, and max. Okay, so moving ahead. So I was discussing about joint plot. Okay, so I'm going to so we're talking about joint plot. And from this, we will deviate to different plots. Okay, so we have a plot here known as SNSC dot joint plot. At x-axis, I need what? I need tip. What is the column? Let me check the column. Yes, column is tip. Okay, and remember, this joint plot will be used for analysis of numeric columns. I'm repeating once again. For analysis of numeric column, it will be used. Okay, will be used for the analysis of numeric columns. So I'm passing what numeric column? Suppose tip. I'm passing the numeric column tips, but pass it in the parentheses like this tip. Okay. Similarly, pass your other argument like y is equal to what is the name? Anything you can choose total underscore bill. Okay, so I passed on x-axis, I need the tip column. On y-axis, I need total bill column. But how will it come to know what these means? I've not used anywhere to tell where the data is coming from. So I have to tell them this data is coming from my DF data frame. Okay, this data is coming from my DF data frame. Just me execute this. And you can see I get a plot. I get a plot here. Okay, I get a plot. What is this? In the y-axis, we have a tip. Sorry, on x-axis, we have the tip. On y-axis, we have a total bill. And it is showing me two plots here. Right now, I have two plots available with me. You may be saying, okay, sir, we have done only joint plot. But actually, this is showing two plots for me. One is the plot. This one, the middle one that you see the small bubbles is known as scatter plot. This is your scatter plot. I'm repeating once again, this is your scatter plot. And whenever you have continuous data, means two floating point data available, and you want to do the analysis, floating point data available, and you want to do your analysis. Okay, what is the relationship between your tip and total bill? Can you see your total bill? If you come here, is a floating point number. Okay, your tip is also a floating point number. So whenever you are this kind of data is a continuous data. Because it can have any value 16.99, 16.91, 16.92, 16.923 something. So these are known as continuous data. So if you want to find the relationship between two continuous numeric variables, what you will use? You will use your what? Scatter plot. Okay, and second plot, it is further showing me this is known as histogram at the top, what you are seeing right now. So in right now, it showed me two things. It is giving me univariate analysis. See here what I mentioned. Histogram is for univariate analysis, right? And scatter plot is for bivariate analysis. But this graph is showing me two things. It is doing histogram, means univariate analysis, as well as your bivariate analysis. The middle graph that we are seeing right now here, this one, this thing we are showing is your scatter plot. Okay, this is my scatter plot, and these graphs that we are seeing here are what? Are my histograms. Can you mute yourself? Actually, background voice is coming, please. Okay, these are your histograms. So now, what is the histogram? We can also plot histogram as well. I'll tell you that. Direct. If I need simply scatter plot, I can do that. I want simple histograms, I can do that. Everything I can do that. This joint plot consists of two plots together. Okay, one is what? One is your histogram that we can see. This is one, and this is one. This is what? This histogram is corresponding to the values of tip. Okay, and this histogram is corresponding to the value of total bill. And you can relate them as well. Let me tell you how first histogram is built on. Understand? Suppose I have a column in which I have a value, suppose 1, 2, 5, 6, and then suppose 15, 20, 30, 35, 40, and 50. Example. Okay, these are something. And in between, I have 45 as well. So how do we plot histogram? First of all, I will have two axes available. In one axis, I will have the numbers. I will have the numbers. Suppose I may have the numbers or I may have the bins. I'll tell you both the things. I may have the numbers or I may have the bins. Suppose I have a numbers, simple. So I mentioned 0, okay, here, then here 1, then 2, then 3, then 4, and so on. Then somewhere it will be 10, then somewhere it will be 15, and there somewhere around 20, and so on. Okay, and here will be the frequency of occurrence. Understand what I'm typing here. On y-axis, you will be having frequency of occurrence. Okay, so what you will do, you will check in your data set how many times the number 1 is occurring. How many times number 1 is occurring? Okay, how many times the number 1 is occurring? You will count that. Okay, let's say we have 1 occurring 3 times. So we will count. Okay, 1 is occurring 3 times. So here we will have a scale. You will move it. Okay, it will be occurring 3 times. We'll plot like this. Okay, then move to the next number. Okay, what is the next number? Next number is 2. How many times 2 is occurring? Suppose 2 is occurring only 1 time. So you will plot it only 1. Make it high up to 1 point. Here it is 1, suppose. Then you will move to the 3. How many times 3 is occurring? Okay, for example, 3 is not there. Perfectly fine, leave it. 4 is not there. 5 is there. So how many times 5 is occurring? Suppose 1 time. So you will plot 5 1 time. Okay, suppose now 6 is occurring, let's say 4 times in your data set. So your 6 will be shown 4 times. Are you getting my point? How am I plotting, please, everyone? This is nothing but frequency of occurrence. Can you observe what I'm doing? Please tell me.
Yes, sir.
Is it okay how I'm plotting? Just counting how many times they are occurring and plotting a bar, sort of bar graph above that. Okay, but normally we don't do that. If we do that, actually what will happen? This will be very, if we are taking consideration every point, it will become very much scattered. Very much scattered. Very much scattered. Okay, so what we normally do, we create bins. Bins means buckets. So what we say normally, okay, whatever numbers are there between 0 and 10, count how many numbers are occurring between 0 and 10. So be buckets. Instead of making 1, 2, 3 individual scale, now the new scale will be like this. It is indicating 0 to 10. Okay, it is indicating 10 to 20. Okay, it is indicating 10t to 30. Okay, it is indicating 30 to 40, and it is indicating 50 to 40 to 50. And here again, same thing, frequency of occurrence. Okay, so let me take a new data now. Suppose data is 1, 2, 3, 3. Okay, then your 11, 12, again 11, 14, 15, again 15. Okay, then we have another data, suppose 22, 22, 23, okay, 24, 25, okay, 20, 23, 24, 25. How many we have taken? 5. Suppose, okay, that would be 5. Then we have some numbers, 31, 32, 33, 34, 35, 36, and 37. Suppose these are the numbers. Okay, so how will I plot it? Let me count how many numbers are occurring between 0 and 10. We'll count them. 1, 2, 3, 4, 5, 6. Sorry, only 0 and 10. So count please. 1, 2, 3, and 4. So you'll come here. Suppose this is the scale 4. So between 0 and 10, you will show 4. You will show 4. That's it. First graph. Done. Now move ahead. Between 10 and 20, how many numbers are occurring? 1, 2, 3, 4, 5, 6. So you'll move up from here and show 6. Like this. Okay. Then come. Between 20 and 30, how many is occurring? 1, 2, 3, 4, 5. Means less than this. So we can make it like this. Okay. Now how many numbers are occurring between 30 and 40? 1, 2, 3, 4, 5, 6, 7. So this is 6. So I will even go further. 7 will be top. And how many numbers between 40 and 50? 0. So that's done. Are you getting my point? How the histogram has been plotted? Please tell me, everyone, now. It should be okay now.
Yes, sir.
Is it okay?
Yes, sir.
Okay. So this is the way the histogram is being plotted. So this is what histogram is. So actually, by the help of this, we get an idea how my data is distributed. So we can see from these plots. What can see? Okay, most of the values of tip. This is corresponding to tip are concentrated here. Most of the values are concentrated here. Means most of the value are concentrated between this range. Between that, his tip is between 2 and 4. Maximum people give the tip between 2 and 4. Similarly, if I want to know, okay, where the maximum data is concentrated, so you can say again here, most of the people paid bill to be between this thing, 10 and 20. So you can get a distribution, how my bill is distributed. I hope it is fine, everyone. Please tell me. You can get an analysis of data, how much data, how my data is distributed. You can get an immediate idea of that. Please, everyone, please tell me, is it fine?
Yes, sir.
Others, please.
Yes, sir.
Okay, so I'm moving ahead, but you can ask me anything. If you have a doubt, please ask me. Okay, and this is what? This is simple plotting. This is simple plotting. This middle one that you are seeing, this is your scatter plot. What kind of relationship you are getting between them? Okay, and you have different options to see in there. Okay, you have different options. What see? Let me delete this. Let me show you something. I'm coming here, and there's a parameter known as kind, and I'm specifying here hex. Let me see what is going to happen. Sorry, what happened? I got an error. Why the error is coming? I think I should specify in that. Okay, quotes if I'm correct. Let me run it. And now see, I just specified a parameter kind is equal to hex. And what is since now it has been turned almost into like instead of circles, you are getting your first of all hexagons, but at the same time, it has been turned into a heat map. If you can observe properly.
Yes.
Right, it's been turned into the heat map, and now you can observe here most of the darker it is, the more the data points are concentrated there. So you can observe here most of your data points between total bill and tip, most of the data points are concentrated here. Higher are the data points, darker it is. So most of your data points are concentrated here. So you can immediately see an analysis what the total people, the people mostly paid the bill between 10 and 20 that we analyze at the peak here itself. You can, if you can relate this way, okay, where these blacks are coming, the blacks are coming here where the peak is, right? Maximum people paid this much bill. Same way where your peak is coming. Can you observe, everyone? It went like that, but we can observe this way. Okay, this is indicating where my maximum points are lying. At the same time, this is very light, so these are very rare. So these things are known as your outliers. Okay, so in interviews they may ask you, okay, what kind of plot you can use to remove your outliers? So you will first answer will be, sir, I can use scatter plot. A scatter plot will give me two options to see the relationship between two numerical variables. At the same time, I will be able to easily see what is my outliers, because most of the points are concentrated in this domain. So if I'm getting something, one or two people only paid bill above 50, right? And very few people, again, those same people paid the bid 8 to 10. So these are nothing but outliers. Otherwise, most of the people considered it here only. Is it fine, everyone? Please tell me.
Sir, can you scroll up a little bit, sir?
Yeah, sure. Just a second. Let me clear it. Yes.
Yes, sir.
Is it fine?
Yes, sir.
Okay. Now, similarly, the kind has other option as well. For example, what I want to see, I want to see a best fit line. The best fit line which defines the relationship between total bill and tip. Okay. We want to find out the relationship between total and bill by a straight line, the best fit line which defines the relationship between total bill and tip. So I can use a line here known as reg, which is known as regression line. Okay. If I run this, can you see I get a regression line. Means this is the best line. Means a line which is describing a line which is describing the relationship between total tip and bill. Total tip and total bill. It is simply a best fit line, the line which can best describe the relationship between total bill and tip. Let me do one thing. I'll share this file with you. So better let me create here. Let me be hex only. Okay, so it is hex only, it is with registration. So it is indicating what? A regression line or the best fit line to describe the relationship. It is trying to find a relationship, linear relationship between total bill and tip. This line is trying to find out the best possible linear relationship between total bill and tip. Please see and tell me, is it fine?
Yes, sir.
Okay,
Yes, sir.
so we are able to do
One
the,
doubt.
yes, please.
That line is, I mean, 1D or 2D?
No, it's a 1D. 1D. We have a 2D only graph. This line, what is 1D graph? Right?
Scatter plot, we have seen like this.
Actually, this is
heat map.
yes.
So,
Right now we are plotting here. It is not a heat map, right? It is all the scattered, all the points here. Okay, we simply plotted this. It's simply a line. Okay, plotted in the 2D dimension. It's 2D, right? X and Y we have. It's not 3D. I think you should be asking it should be a 3D or something. It is just describing the 2 dimensions are there. This is X dimension. This is Y dimension. So it is nothing but Y is equal to MX line.
yes,
Is it fine? Yes, it is a line is equal to Y is equal to MX. It is just trying to find out relationship between tip and bill. So in this case, X will be your tip, Y will be your total bill, and it is trying to find out the relationship. This is our intercept. This is our intercept. So we are starting from here. Okay, this is intercept. This is the line Y is equal to MX. Is it fine now?
Yes, sir.
Okay, so I'm moving ahead with the same thing. Okay. Even without, if you don't need this histograms, okay, if you don't need this histogram, that we also can do, no issue. You can come here. We can simply plot our scatter plot as well. You can simply plot our scatter plot. Just instead of joint plot, just mention scatter plot. If you want to do only bivariate analysis, I don't want to see univariate analysis in the same thing. I just want one plot. Is a joint plot. So 2 plots we are seeing. No, we don't want to see the 2 plots. We want to see only 1 plot. Okay. So I'm just passing scatter plot. Okay. That's it. Read this and let me show you. Let me run this. Can you observe? Same graph is that. In this time, no histogram is there for either for tip or total bill. This is what a bivariate analysis. And remember, we are able to easily find out, okay, these are my outliers. Easily, these are my outliers. Most of the people considered here only. These people are nothing but my outliers. So you can easily select your data frame. How? How you can do? Simply, you can put a filter on your data frame. Okay, give me only those rows where the tip is less than 8. You can do that or not? Please tell me, everyone.
Yes, sir.
Yes.
Okay, otherwise they will disturb your data model. Very much like that. You are working in an organization, and in that organization, what happened? Most of the people have the salary around 50,000, and few people are there whose salary is 50 lakh rupees. So if you found the average, of course, your average salary is going to be affected by a lot if you are going to consider those 2 peoples. Those 2 peoples are outliers for you. Right or wrong? So we will not consider them in calculating average salary. Correct me if I'm wrong.
Sir,
right or wrong, please.
sir, if we would have plotted that MX plus C line.
Yes.
These 2 points would have been, I mean, the farthest 2 points.
Yes.
They would have been on the line.
Yes.
So will it be good to say them this outliers?
I'm not able to get you. Can you repeat once again, please?
Sir.
Yes.
The present plot is good for us to discuss. So some points which are not on the line. This is supposed to going to give us the nature of
no. Actually, this is just giving you an idea. Actually, it is not an ideal model what you are seeing right now. Okay, it is not. These points are far away from this. Okay, so you can. I know what you are trying to mean. If the line points are far away from your data points, right, then you can consider them as your outliers. Actually, that is not the case. You should consider that this is the linear model that you have used right now. Okay.
Okay.
But all the time we will not be using the linear models. All the time
Yes.
we will not be using our linear models. If our model is like that, a linear model, then it is fine. Okay, you are okay. My model is always linear, and any points which are lying far away from that of course, that's why I said, remember, your machine learning knowledge is good, but your domain knowledge is very much required. That is the main thing. Okay, these points, of course, if you're working in a restaurant, you know that most of the people pay bill. Suppose somebody has a total bill of 500, they'll pay a bill of 50 rupees. That you do know by domain knowledge. You are working there. If somebody gave you 500 rupees an odd day, okay, so will you calculate for the analysis as well? You won't
No.
do that.
No.
Same thing. You won't do that. That's by the domain knowledge. That's by the
Yes.
domain knowledge, right? So depending upon our criteria, we select, okay, what kind of model it will be. It will be a linear model, but it will be non-linear model. But yes, certainly, if you are showing sure that, okay, no, it will be linear model, and if some points are lying far away from your best fit line, you, of course, you can consider them as your outliers. I think this is what you mean, right?
Yes, sir. Yes.
Okay.
Yes.
Perfect. Okay. So I'm moving ahead. So we know we can do our easily find out our outliers. And tell me, can you remove the outliers? Can we remove these rows from our data point? We can just put a filter. What a filter in our data frame? The tip should be less than 8. Give me only those rows of the data frame where tip is less than 8. So automatically, tell me, these rows will be gone or not? Others, please. We have done the filtering in the data frame. Remember, we have done the filtering in the data frame. So we can select only those rows of the data frame where tip is less than 8. Or total bill is less than 40, something like that. Okay, you can remove these as well. These as well. Okay, because most of the data points are considered here only. So why we are even bothering? So we can make a filter on, okay, total bill should be less than 40. That's it. That's my prime criteria. So automatically these points will go, which we are trying to consider.
Yes.
Okay. Now similarly, whatever we are doing, okay, this way what will happen? We have, if suppose we have several numerical columns and you want to find the relationship between them, then you get crazy. Suppose we have 150 columns, and if we start to find out relationship between 2 columns at a time, you'll get crazy. 1, 2, 3, 4, 5, 6. Luckily, we have a plot known as pair plot. That will do for us automatically. We don't have to worry. Automatically, it is going to take all your columns, numeric columns, and do the analysis for you. For example, I'm just going to type sns.pairplot, and within that, I'm just going to pass df. Let me see what is going to happen. Okay, it has automatically plotted something for me. And see how it will do. Understand. This is your total bill. And how it is you are going to visualize, take it this way. Intersection of X and Y. At the bottom also, you will be seeing something. Why it is not coming down? Just a second. Yeah. Okay. See, it is total bill. Okay. At the top also, it is a total bill. So I'm talking about do the analysis of total bill. So it understand, okay, we are talking about the same variable. Okay, so what kind of analysis or means at both place X and Y, we have total bill, means we have only one variable which analysis is to be done. So what kind of analysis will do? It will do univariate analysis, and simply it will, for univariate analysis, it will plot its histogram. It will simply plot its histogram and done. Automatically, it will find out what kind of graph is suitable for this kind of analysis. We come down. Okay, here we saw, okay, it is total bill from this. It is tip. So, okay, so now it's bivariate analysis. The same graph we plotted earlier, remember? So we get a scatter plot. Again, this is size, but remember, size is how? Size is by the discrete numbers it is having 1, 2, 3, 4, 5, 6 limited. But tip was your continuous variable. Total base was continuous variable, but it is discrete only. It is having limited value, one value. And how many people were there in the group? 1, 2, 3. We cannot have 2.5 group people. 2.3 people. So it is discrete value. So that's why you are seeing discrete data here between total bill and size. Can you observe, everyone?
Yes,
please
sir.
tell me, right?
Yes.
Similarly, now you can analyze. This is again total bill versus tip. So both are continuous variable. I'm getting a scatter plot. Again, tip versus tip, univariate analysis. Histogram is coming. Size versus tip. Size is again discrete. Tip is continuous. This kind of, again, scatter plot. But why I'm getting this kind of plot? It should be clear to you. Okay. Coming here. Okay. Total bill versus what? Size. Again, the same graph we are getting here, I think. Total bill is what? Total bill versus tip. This is first time I think it is appearing. Total bill versus size. No, this is the graph. Total bill versus size. And same graph you're seeing here. See, Just their orientation has been changed because now total bill has come here and size has come from here.
Variable change.
Right? So yes, X and Y axis has been changed. Same tip versus what it is, tip versus size. That also we have seen. Tip versus size. Okay. Just that now size has come here, tip has gone there. The orientation has been changed. Okay. Now size versus size. Simple. As we know of discrete values. So it is just showing me the count plot. Just showing me the count plot. How many people who have 2? How many people who have 3? How many people were there in the group of 4? So simply it is doing the count plot for me. So automatically it is able to recognize for the numeric columns what kind of data is there, plot is there. Is it fine, please? It's fine, everyone?
Yes, sir. Yes.
Okay.
Last
and one more thing.
Beautifully showing that.
Yes,
this is
yes.
Discrete also.
Yes, yes. It will save your time. Best part is it will save your time. Even you can do further. Suppose now within this, you want to divide something. You want to put something here. Okay. I want to analyze these graph with respect to some categorical column. All these are numeric column that we are seeing, total bill, tip and size. But I want to see this data with respect to some categorical column. Okay. So what I'm going to do, I'm going to add an argument here. U is equal to sex. Sex is a column or smoker is a column. Let me run this and let's see something. Let me execute it. And now see, it has been changed a bit. Okay. Now what is done? Within the same data point, it has divided the data points. How? Between males and females. Sex has 2 entries, males and females. So see, blue are males, orange are females.
Sir,
can you observe? Yes, please.
Sir, can we separate tips like that, sir?
What, beta? What do you want to separate?
So, sir, instead of sex, we can we separate tips, sir? Like how
beta,
much
actually here we pull always a categorical columns. Tip is your continuous variable. See, tip is your continuous variable. It will be having any value 1.0, 1. If you are going to separate it, you will get crazy.
Yes,
How
sir.
many
Yes,
values?
that's what I'm asking.
Is it fine? You'll get
Yes,
crazy
sir.
this way if you try to put it. You'll get crazy, right? So we always put categorical columns in the hue. Instead of this, you have put a sex. You can put a smoker as well. I think smoker is also there.
Yes, 0 and smoker. Yes.
Yes, smoker is there. Yes or no? If I'm correct, yet smoker is there. So you can put a smoker there. Can you see? Observe. This is a smoker. Blue is a smoker, and orange is non-smoker. Okay. So now it's look much more beautiful. Right? So you can create 2 pair plots, in fact, one with the hue of a smoker, one with the hue of sex. If you want to see which is affecting more. Okay. So right now, how much analysis we are doing? See, although we're doing pair plot, but it has become now multivariate, even 3 variables effect we are visualizing at the same time. Right, everyone?
Yes, sir.
Yes, sir.
Okay. Similarly, what we can do that we plot the scatter plot, we can plot our line plot, SNS dot line plot. Okay. And here we are specifying again, let's X is equal to tip and at Y is equal to, we need suppose again total bill. But I know this line plot is not suitable for them. I'll tell you the reason also. You will not get a good plot. You'll get a very bad plot. Data you're taking from DF. Very bad plot. What happened? There's some error. X is equal to tips is there. Tip is there. Tip is there. Fine. Total underscore bill is there, I guess. Let me execute this. Yeah. Can you observe what kind of graph we are getting? It's not communicating proper information. It's not getting proper information. See how much scattered here. But one thing is sure, if you analyze, most of the points are here only. Most of the points are here only. It's very darker. And same thing was available in our X plot if you observe. Okay. But when we use the line plot, remember, this is not a way to use actually line plot. Line plots normally we use when we want to do some analysis with respect to time. On X-axis, there should be some time column like your year or your month, and you want to see the trend. So whenever you want to see the trend analysis, total sales versus years, total sales versus month, how my sales is going or how my revenue is going with respect to time, for that purpose, line plot is very good. For that purpose, actually, we use line plot. Okay, how much? Okay, my revenue decreased, my revenue increased. Okay, 2005, my revenue was this. 2006, it increased. So we were able to see that. Okay, we will be able to see that with the help of this. Is it fine, everyone? Please get the idea when the line plot will be used. Remember, it's an interview questions actually that I'm telling you. When you will use line plots, you'll say, sir, when I want to see some trends with respect to time, right? Then we will go for line. Okay, now I'm moving ahead. Okay, see, similarly, earlier what we said, we plot our distribution plot. Okay, we are able to plot that. Fine. We can plot here is one individually if you want to plot it. Very, very easy. Simple how? I'm saying SNS dot dist plot now, distribution plot. Distribution plot. Okay, and here pass your argument. For example, you want to see any numeric column, tips. Okay, and this is another way of specifying directly. Instead of specifying x is equal to this, y is equal to this, you can directly specify, okay, this is the argument df tips. But better use this way. Better use this way. This is better way of specifying x is equal to this, at x what you want, at y what you want, and where the data is coming from. Okay, so I'm just specifying this. It will also work. It will show me two things, I'm sure. One, it will show me histogram, one the KDE plot. Let me run this. What happens?
Tip, sir.
Tip, okay, sorry. Tip. Let me run this. And histogram. And now you know what is the histogram. And this thing, what you see, when you see here, the graph that you are seeing here is known as your KDE, kernel density estimation, which is nothing but your probability distribution graph. See, if I remove this, can you see right now what is the value I'm getting? Between 0 and 1 only. The values I'm getting is between 0 and 1 just because of this PDE. But actually, I expect a histogram here. But how can the value lie between 0.1? The histogram tells me what? The frequency of occurrence. So I can do that. Just come here and just type KDE equals to false. I don't want to see KDE curve. Execute it. Now it's fine. Can you see the scale changed? Right? This is what my requirement is actually. This is what my requirement. I want to see the frequency of occurrence of the tip. So now you can see most of the people paid tip between what? 0 and 4 only. Very few people hear about the 10. So definitely I get an idea. These are nothing but outliers. You can even remove those. Is it fine, everyone?
Yes, sir.
Okay, so this is same thing, same histogram that we are able to achieve. Even you can plot it without your SEABORN as well. Directly you can plot from that your what was the name? Forgot. Your Matplotlib. Sorry, your pandas directly you can plot. What is the column name? Column name is your tip. Okay, I can directly plot it. df dot plot dot hist. Same thing I'm gonna get. Sorry. See, without even using SEABORN, the pandas has your Matplotlib inbuilt, so you can use that. Whatever plot we are doing, we can do directly with the help of pandas directly. But SEABORN looks much beautiful. I'll tell you the reason is it looks much more better than your graph which you are going to get with the default Matplotlib library. These are very colorful. Okay, so you're able to get the histogram. If you want your probability distribution curve, okay, you want to see that individually. If you want to see inbuilt, the moment I make it true, you will see the scale which is between now 0 and 50 something. It will change between 0 and 1 because KD is nothing but your probability distribution curve. See, the scale changed. Okay, so better if you want to see the probability distribution curve, don't see here. See it separately. How? Come here. And just come here and just make small change, very, very small change. What? SNS dot KDE plot. That's it. And remove this. I don't need this further. I'll get now separate graph. The same graph which were coming here now will be visible like this. Okay, so it is simply showing the probability, the highest probability is between 2 and 4. The highest probability of tip is between 2 and 4 only. Okay, means the probability that which has the highest probability means what do you think the people will get the tip from? So you will say, okay, the maximum probabilities that people will get tip between 2 and 4. Is it clear? Okay, everyone? Please tell me. Okay? Yes. So far what we were doing, actually we were doing our numeric data analysis. Now we will go to some categorical data analysis. Okay, how we can do? So let's go to some categorical data analysis. Okay, categorical data. Let me make it handy. Execute that. Let's see. What are my categorical columns here? Let me come here and we can verify from this one. Okay, we have sex, smoker, day. Okay, sex, smoker, day, even time is there. Okay, even time is there. It's a categorical. So if you want to do analysis of any categorical column, so how can we do that? So again, two kind of analysis will be there, bivariate or univariate. So let's analyze first of all sex column. Okay, how many people are there as a male and how many people are there as female? Okay, that thing we have done in the pandas as well. We can do that very easy. How? df, what is the column name? Sex dot value underscore counts. Remember, we have done that. And after that, if you want to see the numeric, okay, these are the values which are available. But if you want to see the numeric data, the visualization of that, we can do that. Dot plot dot bar. We did that. Okay, same information we are able to see with the respect of that with the help of pandas only, because pandas inbuilt consist of Matplotlib. So it is taking the help of Matplotlib and plotting that. But we can achieve same thing with the help of SEABORN. And you will see that graphs are much better than what we are seeing in this Matplotlib. So we come here and say SNS dot count plot. Okay, dot count plot. I'm doing the analysis of categorical data. And here I'm simply passing what you want to do the analysis. You want to do the analysis of sex. And where you want the data? Data you want from
data, DF.
DF. That's it. Okay, you want to do the sex column and data is equal to DF. Let me run this and then see which graph is better. This one or this one. This is by Matplotlib or the pandas, and this is by SEABORN. Colorful. It looks beautiful. Right, everyone? Information is same. If you can observe, information is same, but it looks much better. Much better. Okay, so we can do simple analysis. For any column, any categorical column you want to do analysis, you can simply use your count plot. Okay, similarly, I want to do the analysis of day column. As I came to know, immediately I can come to know, okay, males are very much higher in number in comparison to the females. Okay, get an analysis. In the restaurant, most of the male wents, females were lesser. Similarly, I want to do the day is also a column, I think Sunday, Monday, Tuesday. So I want to analyze that. So just put day here. Execute that. Okay, so immediately got an idea. Most of the people went when? On Saturday. Right, everyone? Because that is a weekend.
Yes.
Right. So most of the people went on Saturday and Sunday, and mostly on the Saturday, because normally working people want to relax on Sunday. They don't want to go anywhere outside. So whatever outing they want to do, they normally do on Saturday. Okay. Similarly, you can do further. Even you can change. Right now, I'm seeing at the horizontal day. I can change it. How? Let me copy it. Okay. If you want to see, just make it instead of right by default it is showing on the x-axis. Just make y is equal to day. You change that axis. Let me run this and see this dimension change. So whatever you want to, it looks beautiful, better than that. Okay. So you can come here and change the dimension where you want to see the data. It's now saying, okay, day represent the day on the y-axis. So representing the day on the y-axis. Fine, everyone?
Yes, sir.
Okay, so easily we can analyze our categorical data, how many values are there or something like that, very, very easily. Okay, now similarly, suppose what I want to do now, bivariate analysis between a numeric column and for example, a categorical column. Okay, numerical column and a categorical column. Okay, suppose I want to know how much average bill paid as per the sex, as per the gender. Okay, how much average bill paid by the males and how much average bill paid by the females. I want to know that. Okay, so that paid by the male and the female information is available in the sex column, means the gender information is available in the sex column, and bill paid information is available in the total bill column. So I want to analyze something, total bill versus sex. I want to know who paid the more bill, males or the females. That male or female information is available here, but total bill information is available here. Total bill is a numeric column. and sex is your categorical column. So for that purpose, you have bar chart. Okay, for that purpose, you have a bar chart. So I'm gonna say SNS dot bar chart. Okay, and what I want to see, suppose an X axis, I want to see total bill, total underscore bill. On Y axis, suppose I want to see sex. Okay, and data should come from DF. Let me run this. What happened? Did some error? No attribute bar chart. What happened? Sorry, I make bar plot. Bar plot. Sorry, bar plot. I was just spoke. Whatever I spoke, I just write bar plot. Okay. Can you observe everyone? Can you analyze who paid the more bill? Males or females? From this graph analysis, can you see who paid more bill?
Males.
Right? You can change the axis as well. Copy it the same way we did. Just change their orientation. Just change their orientation. Right? How? Instead of that, make it Y and make it X. Let's see Y. Let's execute that. Can you observe now? This looks better, I think, than this. Right? It looks better. Male paid more bill. Yes, please. Want to say something?
No, sir. No.
Okay, fine. Further, okay. So whenever you want to analyze count, okay, means some numeric column versus some categorical column, then bar plot is your savior. Okay. There is one more thing. By default, what it is taking your mean value. This is the average bill that you are seeing. The average bill paid by the male is around 20, something more than 20. An average bill paid by the females are something less than 20. And you know that how to put, if I ask you, okay, put the value, what the average bill paid by the male, what the average bill paid by the female here, you can put it. I told you yesterday how to do that. Okay. If you want to explore that, you can do that as well. If you want to show. Okay, that you can find out. Even you don't need that. If you want to use that, you can easily find out by your pandas. Very, very easily. Remember what we can do? We can do df.group by. Remember or not, everyone? Tell me. Forgot? If you want to do something, df dot group by. Can you recall something? Group by. What column you want to group by? You want to group by 6 column. Okay, it will give me an object. What value you find out? You want to find out the mean value. Execute this. I'm getting total pay. See, this thing you should remember. We have done this or not? Please tell me. This group by statement, we studied or not in the pandas?
Yes, sir.
Okay.
Yes, sir.
So you should remember. Now it is giving me an information. The average bill paid by the male is 20.74, and that is what is available here. Average bill paid by the females is 18.05, and this is what is available here. Average tip paid by the male is 3.08, and by female is this one. So you want to do categorical analysis versus numerical column analysis. Two ways are there, by using a bar plot, or you can use group by function as well. Is it fine, please? Here we have here we have all the numeric columns, and here we have our categorical column. Is it fine? Please tell me.
Yes, sir.
Yes, sir.
Okay. So should I stop for the day? We'll continue tomorrow within 15 minutes. I think 15 minutes more will be there just to complete our SEABORN. Okay. So we'll continue tomorrow. 15 minutes I will take more to complete this. Or if you are free, then we can complete it today itself. If you are okay with that. Tell me.
We can complete it tomorrow, sir.
Tomorrow,
Yes.
sir.
Yes,
Okay,
sir, tomorrow.
So we'll continue tomorrow from here onwards. Okay, we'll continue tomorrow from here onwards. Just 15 minutes are remaining. Your box plot, your whisker plots that we discussed. See, come here. I think we have discussed every plot that I mentioned here. Describe we have seen. Okay. Histogram we have seen. This one is remaining box plot. Okay, this is remaining. Count plot we have seen. Scatter plot we have seen. Line plot we have seen. Bar plot we have seen. Only thing that is remaining is box plot and your violin plot. Okay, that we will see tomorrow. Okay, fine. So thanks everyone. Thanks for your time. We'll continue. We'll finish in
Please
15
share
minutes.
yesterday's video.
Okay, actually what happened, as I was asking you people, actually my space is filled. So can I delete those old videos? Is it fine? Okay, so I'm
Yes,
gonna delete the old videos. Then actually space is filled of the drive. That's why I was not able to fill that. So I'll share tomorrow's video, yesterday's video. I will share all the videos, in fact, whichever are remaining. Okay, so I'll share all of them. Okay, so in the beginning videos, I will delete 10 days videos, starting 10 days videos. Okay.
Yeah, no
Okay.
problem, sir.
Okay,
No
sir.
problem, sir.
Thank you,
Thank you.
Afshuman. Thank you.